Welcome to the tutorial on essential Latex packages for enhanced functionality. I am Kishore Datta from Hindi Girls College, Guwahati. In this session, we will explore key Latex packages that enhance documents formatting and functionality. This tutorial provides simple step-by-step guidance with practical examples to help you master these packages, whether you are a beginner or looking to learn more. In this tutorial, you will learn how to use the color package to add colors to text and elements in Latex for better document design, how to apply the IMS Mat package to write and format complex mathematical expressions, how to align equations and expressions using the tools provided by the IMS Mat package, how to include extra mathematical symbols and commands with the IMS Sim package, and finally how to make your mathematical documents look more professional and easy to read by using these Latex packages. To get started, ensure your system meets the following requirements: a laptop or desktop computer, an operating system such as Windows, Linux or Mac OS, a Latex distribution like MikTeX, TeXlive or MacTeX, an editor such as TeXshop, TeXworks, TeXstudio or TeXmaker. As I am using Mac OS, the examples will be demonstrated on this platform for ease of understanding. Let us proceed. The color package has following features. It enhances the visual appeal of Latex documents. It helps to highlight important text and engage readers. It uses simple commands to color text and backgrounds. To use the color package, start by including it in the preamble by typing \use package and then color. Once added, you can apply color to text using the text color command. So it has two fields. The first one is color and the second one is the text. For example, let's discuss some additional examples of how to use IMS Mat package in different scenarios. Let me open the TeXshop. So here I am removing table of contents, and so the output looks like this one. Now let me use a separate page. So I am giving new page of command, and then I am writing additional features of the IMS Mat package. So let me write an equation. So within mathematical environment, I am writing a square plus b square equal to c square. So this is the output. So it displays an equation a square plus b square equal to c square. Let me use the command boxed so that the equation appears inside a box. Here is the output. You see there is a box here, rectangular box. So using the command /boxed, we can create a box for visually appealing presentation. So I have written here one sentence here: the Pythagorean theorem is given by. So here it appears as it is: the Pythagorean theorem is given by a square plus b square equal to c square, which is boxed. So this feature is useful for emphasizing key formulas or results in your document. Now let's look at the aligned environment. Aligned. So let me write begin aligned and then end aligned. So here I am writing within curly bracket 2. The 2 specifies the number of equation pairs. I am writing the equation x ampersand plus y ampersand within ampersand equal sign, and then z new line, again 2x ampersand minus 3y and within ampersand equal sign, and then let's say 7. So this will display these two equations, x plus y equal to z, and 2x minus 3y equal to 7 with equation numbers 1 and 2. So here ampersand marks is the alignment points, and there is a left hand side the alignment point and right hand side here. So right hand side, in the right hand side you have z and 7. Let me introduce now another command, that is substack command. So I am again using mathematical environment, and I am writing /sum underscore slash substack, and then within curly brackets the 0 less equal I, and then again less equal m, new line 0 less equal j less equal n, and then the parameter a, or instead of a let's say x, capital X ij. So this appears here as summation sign, and there are two stacks scripts. The substack command is used to stack expression in superscripts and subscripts. The substack command in LaTeX is used to stack expressions in subscripts or superscripts. It is used to write multi-line subscripts or superscripts in mathematical expressions. Let's see how the fractions are written using dfrac and tfrac. I am writing here a line. The ratio of a and b can be expressed either by mathematical environment, and then I am writing dfrac command. The dfrac, and there is another one tfrac or by tfrac. A and b. A will be in the numerator, b will be in the denominator. So you see here the ratio of a and b can be expressed either by. So the dfrac and tfrac commands allow for display style and text style fractions respectively. tfrac is for text line command and dfrac is for display. Let's look at the continued fraction, which is in mathematics can be expressed as, so I am using cfrac command for continued fraction. Let me write here cfrac, and then so since it is a fraction there will be two delimiters. So I am writing in the first one 1 plus c, again cfrac 1 plus, again 1 plus cfrac again. Let's see how it works. 1 plus and 1 plus x, let's say. So it will be a continued fraction as shown here. 1 by 1 plus, again 1 by 1 plus 1 by 1 plus x. So in order to write this kind of continued fraction, we can use simply the command cfrac. Let's see how dot can be used to produce various dots. So accordingly we have different commands. For example, let me write here dot variance are dots, one single slash, okay. Then L dots, I am using TT for typewriter, font will be typewriter. C dots, L dots, and v dots, etc. So let me show you how these commands will produce different types of dots. For example, I am typing here a1 a_1 plus a_2 plus c dots and then again plus an. This will provide the expression a1 plus a2 plus dot 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 plus an. All are center dots. So for center dots we can use slash c dots. For lower dots we can use l dots. Let me write the application of all these dots. So I am writing begin p matrix. I want to display a matrix with parentheses. So begin p matrix and p matrix environment, p for parentheses, and elements are a11, a12, and then in the first row, and then c dots, and finally a1n, and new line. Again, in the second row I can write a21, a22, again c dots. So within c dots should be placed within ampersand, because this will be in a single column. A2n, new line. And now we can use vertical dots or diagonal dots. So for diagonal dots we can use d dots. So let me write here d dots. I will show you here in the matrix itself how different dots can be used. So v dots and then p dots again, and then d dots, and finally again p dots and new line. And the final row is an1, an2, because it is a n by m matrix. So c dots and then a n m or nn. So here is the matrix enclosed by parentheses. So I can name the matrix. Let's say AMN is this one. Let me remove this line so it will appear this way. Okay, AMN equal to this matrix. So I am using here v dots, c dots, everything, and d dots for diagonal line. So let me now show you how to use equation numbering using sub equations. We can group equations with the same equation number, but let's just like 1a 1b or 2a 2b. The sub equations environment in Latex allows grouping multiple related equations under a common label. So the sub equations environment groups multiple related equations. For example, within mathematical environment I am writing or begin equation and equation, and equation. Let me write two equations. One is, let's say, a plus b equal to c, and then if I give, since it is begin equation and equation,
I cannot give new line because as you see, you will see immediately here there will be an error. And let me write second equation, x plus y equal to, let's say, z. So you will see an error here, error message, because within begin equation and equation I cannot use new line. Now these two equations are clubbed together, so this way we cannot use begin equation, so we need a separate environment, that is sub equation, begin sub equation, and sub equation. And within begin sub equation and sub equation, let me write begin align and align, so that equations will be aligned about the specific point, and the specific point is here equal sign. So before equal sign I have to give ampersand here and new line. So now let's see the output. You see the equation numbers are 3a and 3b, they are grouped together. So this way we can use sub equations. This feature is especially useful when presenting multiple steps or related equations under a shared context or description. Let's look at some special characters in math. There are several special characters. Let's consider first the volume integration and surface integration, which involve three integrals and two integrals. So there is a divergence theorem which is given by volume integral. So I am writing three i's here, I int. A single int represents one integral and triple I int represents volume integral, and I am using the operator nebula. I will show you here in the output how nebula will appear. Then double integration, so slash I and t, these are special characters in math. F dot ds, these are basically used in vector calculus. So the divergence theorem is given by volume integral divergence of f dv. This del is represented by nebula operator, and since these are vectors, so I can use bold symbol. Nebula is bold and f is also vector, so I am giving math vf, so it appears like this. So they are now represent vectors. Similarly here math vf f and ds surface area, so math vf s. So this is the divergence theorem. You will see in any mathematical book, this is the divergence theorem. So volume integral we can give some suffix, let's say v, integration over the volume, and here integration over the surface, s for surface. So this is the correct expression for the divergence theorem. So we can use here the special characters like triple I int and double I int for volume integration and surface integrations. Let me show you how to use limits, how differently we can use limits. Let's look at limit placement. So within mathematical environment I am writing a sum, no limits. There are two options, one is no limits and another is limits. So no limits, I equal to, let's say, 1 to n, and then a space. So for space I am using q quad, and then again sum. Now I am using limits, again the same limit, I equal to 1 to n. Let's see how they display the summation sign, no limits and limits. So here is the difference. So no limits places the limits, next to the summation symbol, making it compact and suitable for inline math. But limits places the limits above and below the summation symbol, which is typically used in display math mode. By default, in display math mode, summation limits are displayed above and below limits. In inline math mode, limits are displayed besides the summation symbol, no limits. So let's look at nested cases. Cases we have discussed already, cases environment. Now let's look at nested cases environment. So I want to display something using nested cases. So within mathematical environment, I am writing a function f of x equal to begin cases, and then once I start begin cases, then it should be closed by end cases. And then the first condition, first variable is, let's say, a, and condition is if. So if I have to use text is available in math mode, so text if x greater than 0, new line. Then I have another cases, so I have to use begin cases, end cases, so that's why it is called nested cases. So begin cases, end cases. Within begin cases, end cases, I am writing b, f x equal to b if x equal to 0, x equal to 0, new line, and fx equal to c if x less than 0, and both are the conditions for otherwise. So I have to use here otherwise, text otherwise. Let's see how it displays this condition. So here is the output. You see f of x equal to a if x greater than 0, and b and c otherwise. So otherwise means if x equal to 0 it is b, if x less than 0 it is c. So this way we can use nested cases. This is very useful when you express a function with different values for different conditions.
Now let's proceed and go to the AMS Math package. The AMS Math package is essential for presenting mathematical contents in a clear and professional way. It simplifies the creation of structured mathematical expressions. It provides environments like equation, align, gather, and matrix for various types of formatting. In order to include the AMS Math package, we can use package command. So use package AMS Math will do the work. Let's discuss the align environment. So the align environment aligns equations vertically for better readability and comparison. It aligns equation at specific points like the equal sign. It uses ampersand to specify alignment points. The align star environment works similarly but suppresses equations numbering. For example, if we write within align environment, begin align and align, I am writing three equations or expressions. The first one is a plus b equal to c with ampersand sign before the equal sign. Then new line, and d plus e ampersand equal f, again new line, g plus h ampersand equal I. So this will display these three equations with equation numbers, and all are aligned about the equal sign. As you see here, the aligning environment aligns equations and adds numbering automatically. But if we write align star, if we use align star environment, then let me do it. Begin align star and align star. As we see here, the align star environment works the same way but removes the numbering. Let's look at the getter environment. It is used for centering multiple equations without specifying alignment points. In this environment, each equation is centered individually. For example, if we type begin getter, end getter, and within this getter environment, again there are three equations: a plus b equal to c, d plus e equal to f, g plus h equal to I. Now, as you see here, each equation will automatically appear centered. Now let's look at the multi-line environment. This multi-line environment used to display long equations that span multiple lines. The first line is aligned to the left, the last line is aligned to the right, and the intermediate line is aligned centered. For example, if we type multi-line environment, begin multi-line, end multi-line, and then there is a long equation, let's say a plus b plus c plus d plus e plus f plus g plus h plus I plus j, and the new line equal x plus y plus z plus p plus q plus r plus s plus t. So as you see here, there are two lines here in the equation. Equation is numbered as 7. So let's look at now the split environment. It is used to break a single equation into multiple aligned parts. However, it must be used within another environment, such as equation. For example, if we type begin equation, end equation, and within equation environment we write begin split and split, and then the equations, let's say E equal to mc square plus frac half mb square, ampersand for alignment, and then quad for a small space, plus integration from 0 to infinity, then frac sin x by x, and then dx. So this will appear as this. So there is an alignment about equal sign. The first equation appears as E equal to mc square plus half mb square, and the second expression appears as plus integration 0 to infinity sin x by x dx. So this is the usefulness of split environment. Here the ampersand symbol is used to align equations at a specific point, usually an equal sign or another operator. Let's discuss the cases environment. The cases environment is used to define piecewise functions, where a function is specified differently for various input conditions. Each line includes expression on the left and conditions on the right, separated by the ampersand symbol. For example, if we write within equation environment fx equal to, now begin cases, end cases, and within begin cases and cases we have x square ampersand slash text if x less than 0, new line x plus 1 ampersand text if x greater equal 0. So this will display as fx. So this kind of expressions appear in mathematics. So fx, the function f of x, has two different values in two different regime. So it will take value x square when x less than 0 and x plus 1 when x greater or equal to 0. So this kind of expressions or equations can be easily written using cases environment in LaTeX. Now let's proceed and look at AMS-SIM package. The AMS-SIM package extends LaTeX capabilities by adding a wide variety of mathematical symbols. To load the package, add the command use package AMS-SIM in the preamble. And this will help us in various ways. For example, MathBB N, capital N, to represent the set of natural numbers, mat BB capital Z to represent set of integers, mat BB capital Q to represent set of rational numbers. Within AMS sim package, there are various logical symbols and relational symbols. For example, if I write / for all, this is a command to represent for all symbol. /NEG to represent not equal to, /equiv to represent equivalent to, /approx to represent approximately equal to, /sim to represent similar to, /sim-eq to represent asymptotically equal to, and similarly /prop2 to represent proportional to. And there are many set notations included in AMS sim package. For example, /empty set to represent the phi, the empty set symbol, /subset to represent subset, subset to represent superset, /cap to represent intersection, /cap to represent union, /not in to represent not an element of, and /in to represent element of. These are the set notations, and they can be easily produced in LaTeX using AMS sim package. And there are arrows and directions. For example, if I write /right arrow with R capital, it implies left right arrow to represent if and only if, left arrow to represent the left arrow, and similarly up arrow to represent up arrow, down arrow represents down arrow. Before concluding, let's assess your understanding with a couple of quick multiple choice questions. This will help you review and reinforce what we have covered in this tutorial. That is the first question. Take a moment to consider your answer. Which command is used to change the color of specific text in LaTeX? Options are /color, then color text. Option B, text color, color text. Then option C, set color, and option D, define color. So the answer is text color, and there are two fields, color and text, as we have discussed earlier. Question 2, which environment should you use to center multiple equations without aligning them at a specific point? Options are gather, multiply, align, and split. So the correct answer is gather. Then question 3, which symbol is produced by the command /matbb and then within curly bracket capital R? Options are set of natural numbers, set of integers, set of rational numbers, and set of real numbers symbol. So the correct answer is the symbol for set of real numbers, that is blackboard style capital R. Now let's proceed to question 4. Which of the following commands is used to load the AMS sim package in a LaTeX document? Options are load package, AMS sim, import package, AMS sim, use package, AMS sim, and then include package, AMS sim. So the correct answer is use package, AMS sim. let's look at the last question. What does the AMS SIM package provide in LaTeX? Options are a set of new fonts for text, more color options for text, a method for equation alignment, additional mathematical symbols. So the correct answer is obviously additional mathematical symbols. To conclude, this tutorial highlighted key features of LaTeX math typesetting with the AMS math package, including align for alignment, multiply for long equations, cases for piecewise functions, and gather for centering equations. The AMS SIM package enhances your toolkit with symbols for sets and specialized mathematical concepts, complementing AMS Math to create clear, precise, and professional documents. By combining alignment, customization, and versatility, LaTeX makes mathematical content clear and visually refined. We hope this tutorial helps you enhance your documents effectively. Thank you.